like a Hellcat.
Good morning, guys. Today I would like to introduce you the concept of SolidWorks simulation. So I think today we have to discuss about that thermal simulation. For that, I have already created a model having three-layer structure. Okay, guys. Actually, this will be our model. This is nothing but a three-layer model, and I will show you. This is just a outer box, and this is the second box, and this will be the tail box. I just simply made the tree, and okay. So we have to do one thing that we need to have a thermal simulation. Actually, we need to assign three independent material for each layer. Then we need to simulate this model. Actually, we would like to go for a transient simulation. Actually, which is a time dependent simulation. It is nothing but actually how much will be the temperature inside the box after heating the external body. Thus, we have going to give 100 degrees Celsius in the outer surface, and at that time, the 30 degree will be the atmospheric temperature. That will be our condition. So we are going to start the simulation. Okay. So initially, we need to add in simulation from the SolidWorks add-in here. Okay. I have already enabled the key. So the simulation tab will be here. Okay, and after that we need to have a new study. Okay, from where these much of simulations, the options will be here. Okay, so we need to select the thermal simulation. Okay, for thermal simulation we have to give in suppose I am giving three layer. Okay, three layer thermal simulation. Okay, just you have to give a name for the file. Okay, now this the simulation dialog box, the part is open here. So here the parts and the connectors and temperature loads and mesh. These all the options are over here. So initially we need to give the material for this. So initially the first layer that okay, this will be the outer layer, so we have to give the name here, edit or apply or edit material. Okay, now this part is open here. So suppose we have to assign anything from here, and so alloy steel that I have given in the outer layer. Okay, and this mass density and the thermal conductivity and the specific heat. These all are the parameters that we required for this simulation. And so this all data is available here. Then no issue. We have to directly apply this material here. Okay, the material is applied now, and you have to see that the color has been changed. The same way we have to assign the second material also. Okay, suppose we have to go for any plastic, suppose nylon. We have to PVP. Okay, actually that's all data is not here. So nylon 6. Okay, I think the under data is here. Okay, so the mass density here and the thermal conductivity is here and the specific heat is here. So we have to directly apply this. The second material, the second will be the nylon. Okay, so we have assigned the nylon for the second material, and the third one that we have to assign. Okay, that's already assigned, and now the pending one is this only. So edit material. So we have to apply other plastic or silicon rubber. Is that values here? No, actually it's not here. And Okay, no issue. We have to go for some other material. Specific not apply. Symbolize. Okay, I think this will be the better. And in the intermediate layer, we have to apply sing. Okay. So now we have applied the entire material, and we have specified the material for the 3 layers. So at right now we have to have the thermal loads that we need to apply. Before that, we have going to do the transient simulation. That is the time dependent simulation. For that, the purpose of the transient simulation is nothing but which is just like a time dependent simulation. Suppose we have to heat on the outer layer, that's this layer, that's alloy steel for 100 degree for 5 minutes. That will be our condition. So we have to select here the simulation and the properties, and here the now it is in the steady state, so we have to convert it into transient. Okay, the total time it will be in seconds, so 5 minutes to 560, that means 300 seconds, and the timing given will be 10 seconds, suppose. Okay, and we have to click OK here. Okay, now it will be okay, and okay, now we have to add the thermal load, the temperature load that we are going to add. So for the transient simulation, initially we need to add the initial temperature. So select all exposed faces. So the SolidWorks itself automatically dictates all the surfaces. So now we have to add the temperature. So atmosphere temperature will be 30 degrees. So I have also applied the 30 degrees Celsius here. Okay, now we have to tick the OK button. Okay, now the temperature is applied here. You can see all the surfaces are selected, and 30 degree temperature is applied here. Okay, you can see here, and okay, and now we have to apply the 100 degrees Celsius temperature outside the layer. For that we have to go again at the thermal loads and the temperature, and select all people and temperature. Just click here and select the faces, this one and this one, also this one. Okay, now we have selected all the exposed faces, so we have applied temperature in these faces. So suppose we have to apply 100 degrees Celsius. Here we have option Kelvin, Fahrenheit and Celsius. You have to select any option here. Okay, so we have to tick OK here. Now you can see here, and this will be the ambient temperature 30 degree that we have applied for the entire surface, and also we have the outer for the outer layer we have applied a 100 degrees Celsius temperature. Okay, so now we have to move to the meshing and create mesh here. Okay, here we have an option that's the coarse mesh and the fine mesh, which means while we have selecting that coarse mesh, the reading will be not much accurate, and if we have more to the fine mesh, the value will be more accurate. Okay, suppose actually for the analysis having much accuracy, you should go for the fine mesh. Now we have a experimental purpose, so I have just go to the slightly coarse mesh, because when we have gone to coarse mesh, the time taken for the meshing as well as the iterations, that will be less time only. So I just go to the coarse mesh. Okay, now I have put the tick mark here. Okay, now the meshing has been started. So let me see in progress. Okay, done. So we have completed that meshing. Okay, you can see here, this is the entire body has been divided into small components. So in the each layer there will be the calculation will be happening. So now the entire part is completed. Now we have to go for the study. So now the simulation will be started. Okay guys, so our simulation has been completed. You can see here, and this will be the temperature graph, and this will be the temperature plot here, and this is the Kelvin. So we have to convert it into chart option. Okay, and settings. So okay, chart options, and there is the option scientific 14 general. Okay, 80 to 90 degree, and normal. Okay, here the position that preferred. Okay, we have to place here, no issue. So the definition, and this will be Celsius only, and the temperature in the experience at gradient, that for what direction of temperature scale that we record, everything is available here. So we have to take the temperature here. Okay, sorry. Okay, now we have to put the tick mark. Okay, now it is converted into Celsius scale. So here you can see that okay, there's an option Pro. Okay, you can see here. You have right click from the out result, and there's option Pro. Okay, so for that probe, one sec. Okay, now it's visible. So at any point we have to, what will be the temperature that we have to get, the outer surface, it will be the 100 degrees Celsius, and now we have to move to inner degree, and here you can see that's a 58 degrees Celsius. Actually we have selected that the atmospheric condition will be 30 degree, and when we have heated 100 degrees Celsius outside the layer, and the temperature, so after 5 minutes the temperature inside will be 58 degrees Celsius. Okay, this will be our result, and at the bottom portion there's slightly higher temperature we have shown here. So we have to check, that's 199 degrees Celsius. Wow. So the 199 degrees Celsius may be due to there is a 3 layers here, that's why there is some pressure, there's a stress may be happen, so that's why that much of temperature there. Okay guys, these were for that transient simulation, thermal simulation. So if you have any doubts or any clarification, you have to put comments below, and if you like this video, please like, and please subscribe. Okay, thank you for watching.